Okay, today is, I guess you could say, a review for the test, but we do have one more concept that I haven't talked you through, so there's one new thing buried in here, and it has to do with polar equations. Can be, you can get two polar equations and see where they cross. The slow but effective way is you graph both of them. But there's a much better way than that, because graphing is really slow. That's why I only gave you 4 problems for homework last night, 2 of which you could use a calculator on, because they take a long time. So if you have this on the test, and you have to find where two polar equations cross, I'm going to show you a better way than just graphing them. All right, so let's start today with a little review of polar. When I first all started, I told you points like, 2 comma pi over 6, and you'd find them. All right, I want to do that, except I want to start with the tougher kind where they start with a negative. Negative 4 comma 11 pi over 6. Now, like I said before, that doesn't really exist. But there is a point that does exist in that spot. And what do I mean by it exists? Because on a polar graph, your r has to actually be positive. This is kind of like directions to a point. So my question is for you, put a dot in the right spot and tell me, where is that point? What I mean by that is it has to have a positive r to actually exist on a polar graph. All right, so figure out where it is. Then give it to me in polar with a positive r. R must be bigger than 0. And then tell me the rectangular coordinates. What comma what? I'll pause for a moment while you see if you remember those key concepts from the beginning of the polar unit. There we go. Did you find that your spot in question, first you can go to 4 comma 11 pi over 6, just to kind of see where that is. Here's where 11 pi over 6 is, a whole bunch of pi over 6s, right? And that's where 11 pi over 6 is. And the distance of 4, is that the spot I told you to go to, though? No. This was our directions to get there. It's really kind of related to that, but when it's negative, then it has to get reflected back across the origin and over here. That is our spot. And that spot, you're supposed to give me the polar coordinates for. This was just kind of to help us find that spot. So that spot's at 4 comma, well, again, if pi over 4, pi over 6 is kind of the angles we're working with here, then this is a whole bunch of pi over 6s. How many pi over 6s? 5 pi over 6. You should have said 4 comma 5 pi over 6 gives you the polar point that actually exists. The other one was just kind of like a shadow of the other one, and then you just reflect over to it. All right, now we're talking about the rectangular. The rectangular is the x's and y's. Now, you can do this. I think it actually isn't much faster to know this fact, but it's important, especially when we do conversions, that you know x is the same as what? R cosine theta. And what's y the same as? R sine theta. Now again, I think it's just about as fast to just draw the picture to get your x and your y. But boy, later when you have to do conversions and you got to change your stuff that's in x and y coordinates into polar, it's really important to know x is that and y is that. Wherever you see an x, you can put an r cosine theta. Wherever you see a y, you can put an r sine theta. All right, so now let's just use, if this is 30, I know all of the angles and all the sides and stuff, except the sides normally would be 1, 2, root 3. Why is it not that this time? Yes, sir? Because the length of the what is 4? Yes, the hypotenuse, also known as the what in polar? The radius is 4. Okay, so that's got to be 4. But again, it's not super tough here. I can make the classic, which is 1, 2, root 3, pausing for a moment. Okay, back to, we are going to find cosine, r cosine of theta. I'm just going to not follow this slavishly. I'm just going to look at this and say, what's this x? I'm going to go x is to root 3 like 4 is to 2. X is to root 3 like 4 is to 2. Well, 4 over 2 is 2. So then I just have to multiply both sides by root 3, and I got 2 root 3. That's a way to do it. Option B, you could have done r, which is 4, times cosine of theta, which is cosine of theta is cosine of 30. And let's make sure that I don't have a negative running around in here or something. I do. It's supposed to be a negative side.
Negative 2.
Yeah, this side has to be negative because it's going in this direction, so it should be negative 2 root 3. I apologize. All right, so 4 times cosine theta, and this cosine theta is cosine of 30, but it's cosine of 30 in this quadrant, which makes it negative. Cosine of 30 normally would be positive, but cosine of 30 is actually over there. Technically, we're doing cosine of 5 pi over 6. All right, so all said and done, I have negative 2 root 3, and that, if you think about it, is just saying it's 2 times bigger than normal. You know, normal would be a 2, and now we got a 4. It's 2 times bigger than normal. So I can just say 2 times bigger than that. So it's 2. Y equals 2. So there's my x and y for my rectangular. My x is negative 2 root 3, and my y is 2. Okay? How many of you would have got that one right? Good. Now let's talk about the kind of the next level. That's changing points back and forth between polar and rectangular. Here's how you change equations back and forth between polar and rectangular. That is a very simple equation. How can I change it to polar? Well, if you knew what x was in polar, you could put it there. What is x in polar? R cosine theta. What's wrong with it now? Still got a y in it. What's r? Sorry, what's y? R sine theta. And then, if necessary, you might have to solve it for r or solve it for theta. Now, just to clarify, do you get I can divide by r on both sides? And some of you are going to be bothered by the fact that that r is going to just disappear, and that this r, you might think that that can cancel like that, but it actually can't. Okay. What you could do is, if I divide both of them by r, then I could say sine theta equals r cosine theta over r plus 7 over r. And then, yeah, these r's can cancel, but I still have an r left. Is it okay to have an r left? Yes. As long as you have r's and thetas, you're in polar, and it's good. Now, if I had to solve this for r, it would be a pain. When they're really a pain, we don't usually make you solve them for r or theta. All right, one more thought. Let's say we had this. R sine theta equals r cosine theta, and I was trying to solve this thing for theta. Divide by what? Not that time. What? Divide by r is correct, but you could do more. No, don't make it so complicated. You just are trying to get all the stuff onto the same side.
Oh, so equal
Now, cancels, cancels. And what's cosine over cosine? And what's sine over cosine? Look at that. And couldn't you solve that? I hope so, because that's one of the things that we did in last chapter. This is kind of like our, again, this whole unit is all review. Tons of review stuff that you have to know. All right, so take a moment and solve this one. I'll give you a little hint. It's 1 over 1. And yeah, you can draw a triangle. This is not a quadrantal. You can draw a triangle with an opposite and adjacent of 0. In fact, there's 2 answers for this. I'm going to pause while you give that one a try. Okay, we're back, and here is Our answer to tangent of theta equals 1. We get two answers. One of them's pi over 4, one's 5 pi over 4. And what did I do? I solved for theta. They can make you do that. All right, one more thing. I always try to relate things back to stuff you understand. And I hope that you would understand, if I gave you this question, that those two lines are rectangular, and one of them, I'd like you to just sketch both of them. Just sketch them, and you'll see kind of generally where they cross. Try this one. Because that'll remind you then of how we could solve the next type, which are in, what are they called again? Polar. Because we're going to do the same basic thing when we do polar. I don't need you to be super accurate here. Do you get the idea that one of these has a y-intercept of 5 and has a slope of 1, and therefore is kind of like that? And the other one's got a slope of 3x and has an y-intercept of 0, so it'd be kind of like that. Do you get generally that they would cross somewhere? And that is the solution. Now, could I have done that in a faster way? Definitely. I could have just said, since y equals 3x, substitute this one into this one. Well, where does it go? Well, y is 3x, so I put a 3x right there. Do you get I can solve that really easily then? Same thing with polar. Let's say you had that. Well, it's the same concept. Could you graph both of them and see where they cross? Yes. But is there a faster way? Probably, considering I'm asking that question. So r is 2, right? So I put a 2 in there. And there you go. Now, I happen to make this one not work out real nice. I wish I would have made that a 4. So I'm going to cheat and make it a 4. Divide both sides by 4, and then why is that nicer? Because it's cosine of theta equals a half, and you've answered that question like 33 times by now on tests. How many angles did you probably get? 2. Is this inverse trig? No, so therefore there's 2 answers. Remember, on inverse trig, we would cut it down to only 1 if this had been inverse cosine problem. Okay, so moral of the story, you can substitute one equation in the other and solve. All right, I'm going to give you one more like that. R equals 1. 2 cosine theta equals r squared. Would you please solve it? Where do they cross? It's not that hard, yes, once you realize what's going on. Hopefully you won't get lost in translation on this one. Two cosine theta equals r squared. Well, if I square both sides, r squared is 1, so it's 1. There we go. Now, did I change that into rectangular? No, it's still got a theta in it. I was trying to substitute it in so that I could see where these two graphs would cross. And what I'm going to have is angles. Divide by 2, divide by 2. Cosine of theta equals a half. And again, hopefully you can give me 2 angles for that. What that's going to mean is, here's your polar graph. And one of your things might have been a circle that's here. And the other might have been a circle that's like right there. And where did they cross? Right there. And it'll tell you what angle they crossed at. So let's say that the answer comes out to pi over 6. Then apparently that's the angle that where the two would cross. All right, so just finish it. Solve cosine of theta equals a half. It's good practice for you. We got to be able to review all the old stuff. And we'll do more of that tomorrow. Okay. All students take calc. Cosine's positive, so it can't be here, can't be here. It's got to be here. Cosine's adjacent. Hypotenuse. Root 3. What's crossing the root 3? Pi over 3. Whole bunch of pi over 3's bring you down here. So pi over 3 and 6 pi over 3? No. 5 pi over 3. Pi over 3 and 5 pi over 3. If we were in inverse trig, I'm just reminding you, so again, it's review. If we were in inverse trig, we would actually have said negative pi over 3. You know what I'm talking about? Well, we are not an inverse trig, and therefore, the only time you really use those negative angles to solve these is in inverse trig. All right. So pi over 3 and 5 pi over 3. Raise your hand if you had that one right. Excellent. And again, what was that? That was where this, which has a radius of 1, so it's a circle, it looks like that, would cross this one, which I don't know what that looks like. I really don't. Okay, I'd have to graph some points and see where they would cross. And eventually, let's say, well, I happen to know the answers. The answers are at pi over 3 and 5 pi over 3. So here's pi over 3, and here's 5 pi over 3. So maybe this other thing is like a circle that goes like that. I don't know exactly what it looks like. Yes?
So why don't we make it an inverse problem?
Could I do an inverse trig problem? Absolutely, but then I would be limited to only one answer. I don't want to be limited. All right. So now your next step for this is I'm going to give you some that I want you to translate from rectangular into polar. Hint, this triangle always contains all the equations you'd need to be able to translate and swap out things like x squared plus y squared and put in other things. And you want to get this out of rectangular and into polar. Pause for a second while you give that a try. I like it. We'll use the x squared plus y squared equals r squared, and there it is. There's an x squared plus a y squared. And I'm going to pull them out and put in r squared. R squared plus 3x. We still have a 3x left. What am I going to do with that? Is there anything you could swap out an x for? Yes, sir. And instead of x, I'm going to put in r cosine theta. You are correct, sir. And have I got it down so it's only r's and thetas left? Good. Then, well, I know there's other numbers, but the point is there's no x's and y's like there were in the beginning. Now there's only r's and thetas, so therefore I have translated this into polar. That's all you'd have to do to translate it into polar. Now, could they make you solve it? Yeah, this one's really brutal, though, so it'd be really tough to solve. But if it was a simple one and they'd say solve for r, you'd have to solve for r. But that's just algebra. We will not make you solve something like this for r, because that would be really, really tough. There's an r buried in here. There's an r out here. Yes? I pulled them out and put in what? Why did I do that? Because x squared plus y squared is r squared. Okay? So that's kind of like a flag, is if you see an x squared and a y squared, oh, that's an obvious one. You pull out the x squared and y squared and you put in r squared. What if you see an r squared? Well, I can go the other way then, right? So what if they have r equals 3? And you go, well, I don't have r squared, but I could square it, and then I would have r squared. And then you say r squared equals 9, and then can't you do the same equation? X squared plus y squared equals r squared. That's in polar. Once I pull out this and put in, now it's in what? Rectangular. Both of them are circles. I can tell this is actually easier if you understand it. It's just radius is 3, and you draw your circle with a radius 3. This is much more obscure, but it's we actually studied that in higher algebra. It's a circle that starts at 0, 0, and has a radius of the square root of that, which is 3, and so still a circle. Radius of 3. Okay, so here's one more. R equals 3 cosine theta. Now, this one, when you square both sides, it gets icky on the right, and I suggested an alternate method. Do you remember it? Multiply by r. Some people have good short-term memory and have actually maybe turned it into long-term memory. And I'm going to strategically place that r. I can put it anywhere, but can you guess why I put it there? Because now I got r squared here, which is x squared plus y squared, and I got r cosine theta. Woohoo, I know that one. What is it? Didn't I just change it into rectangular? Because all the r's and thetas are gone. All right. Okay, so that's the concept of translating equations from polar to rectangular or from rectangular to polar. If you only really need two things for doing this. So whenever you, oh no, not that, sorry. X squared plus y squared equals r squared. And you also have to know wherever you see an x, what can you put? R cosine theta. And wherever you see a y, what can you put? R sine theta. So if you see an r squared in the problem, well, you're probably going to substitute it for that. If you see an x in the problem, you're probably going to put in that. If you see an r sine theta in the problem, you're probably going to put in that. And where did these all come from? R, x, y, theta. You can generate all of those things from that little picture. Okay, now that's everything you have to know. So, the one thing I think you're weakest at is what we did yesterday, which was graphing. I mentioned graphing polars, but wouldn't actually do one today, I mean. Let's say I had to do that one. Now, a couple thoughts. Remember on these, it's way easier to pick your thetas because you don't want to try to solve and find the angle that gives you like 4/5. You won't be able to do it without a calculator. So you might as well pick the angles and stick in the angles. What are easy ones to do? Pi over 6, pi over 3, pi over 2. Don't forget pi over 4 and pi. Good. Those are all good ones to do. And then also don't forget 0. In fact, all the quadrantals are easy to do. All right, I don't need you to do all of these. I'd like you to try a few, though. I'm going to show you how to do this one just to make sure you understand what's going on here. Pi over 6 is in the 30, 60, 90 triangle, right? 1, 2, root 3. So if I'm going to do sine of this, I'm putting the pi over 6, grabbing it and putting it in right there. Sine of pi over 6. Sine of pi over 6 is, I have that one memorized. I told you to memorize it. 1/2. Good. And what's 1 plus 1/2? 1 plus 1/2 is 1.5. There we go. 1.5 comma pi over 6. Now, some other things are going to come up. You're going to end up with a root 3 in this answer, of course. And when you do this one, guess which root you're going to have in that one? Root 2. Now, you should know these. Root 2 is about 1.2. And root 4 you already know. Root 3 is about 1.6. No, wait, I think it is 1.6. Sorry. Somebody double check square root of 2. I think it's 1. No, check square root of 2. Somebody's got a calculator. 1.4, thank you. I was feeling like that was off. Sorry. There. I'm leaving those up there because you're going to end up needing to get an answer for something like this, and it's going to say like 1 plus root 3. You're going to be like, what the heck is that? Well, 1 plus 1.6. So it would be like 2.6, okay? All right, I want you to find 1, 2, 3, and 4. Do all of those. Do those 4 that are left. Pi over 3, pi over 2, pi over 4, and pi. And I want you to work with somebody. I'm going to pause for a second while I do this. Okay. So we are going to not only get these points, we are going to graph them. I'm going to call in some different groups to tell me what to do. Row 1, set of people, number 4. I'm going to make that you two. Jasper, what did you guys get when you had put in pi over 3? Sine of pi over 3 would have been root 3 over, am I doing this right? Square root of 3 over 2. Good. And then did you get that this is a little less than 1? I'm going to call it like 0.8. All I know is it's a little less than 1 because Root 3 is like 1.6. 1.6 over 2, I think that's actually about 0.8. So that's 1 plus 0.8, 0.8. Is that what you guys had? Or close to that? All right. Then pi over 2. If I'm going to put in pi over 2, let's see which group's going to tell me that. It's the same exact group. I'm not going to do that again. It really wants to be row 1. All right. Last group. That's you guys. Leaf, tell me what to do to put in pi over 2. Okay, the talking needs to stop. Pi over 2, yes. How do you do sine of a 90? You take the y of sine at 90 is right there, but the y of what? At what point is that? 0, comma 1, and therefore the sine of that is the y of that, which is 1, and then this is 1, and then 1 plus 1 is 2. Raise your hand if you had a 2 on that one. Okay, good. Then the next one, pi over 4. Let's just skip right to the answer. You got an answer for that one? All right, then you get to work it through with me. So, where's pi over 4? I'm putting it in here. What is pi over 4? Do you know that one?
It is square root 2 over 2.
Okay, hold on. I'm going to check and see if you're right on this. 1 root 2. So you say that the sine of that would be 1 over root 2. I agree. So if this is 1 over root 2, now my answer is 1 plus 1 over... Would you agree that this number is 1 over 1.4-ish? And therefore it's a little less than 1?
But it's plus 1. So it's
Right.
2 divided by 1. Wait, no.
1 plus a little less than 1. I'm going with 1.8-ish again.
It'd be 2.8.
I believe that. Either way, it's going to come down to a 1 point something, and I could be off a little bit, and it's okay. Because when I graphed this, and it was really supposed to be, let's say, 1.6, do you think I can tell the difference between 1.6 and 1.9 on a graph? No, it's like it's almost in the same spot. Okay, so that won't burn you. Now, if you thought it was 2.8, I could tell that's way off. Okay, so anyway, next one is a pi. If I want to do sine of pi, pi is right here. Sine of that is the y, which is 0. 1 plus 0 is 1. Raise your hand if you had all of them right or only one wrong on this list. Okay, good. Now, 1.7, 1.8 is pretty much the same thing. I'm not saying you might actually be more right than I am on that. Then, you need to graph them. I don't want you to get lulled into sleep thinking that's all you'd need. You need to then be able to graph these points. So well, do you notice all my numbers are less than 2? Do you get of the graph that I just did, then I would never use anything outside that circle? So I kind of made my scale a little wacky considering that 2 is the biggest thing that I could have. So I might as well go like this. Here's 1, and here's 2. See what I'm saying? So I may as well use a proper scale because the biggest it'll ever be is 2. All right, so now 1.5 comma pi over 6. Here's where pi over 6 is. Where is 1.5? It's about right there. Does the line actually exist? Nope. It's just there to help me figure out where to put the dot. Would you please, if you haven't already, graph all 1, 2, 3, 4, 5 dots. I'll pause for a minute while you do. All right. I'll get a group to tell me where to graph this next one. This is row 4, group 1. That's you again. Lucky you. Dice like you. How am I doing this? Think.
You would make a 60-degree angle.
Excellent. Here's my 60.
It would be a little greater than your first dot.
All right. So the first dot was at 1.5. I agree. This one goes a little bit farther out to like 1.8. So there. Good job. Again, that line doesn't exist. That's just me helping to figure out the right angle. Okay, now let's graph this point right here. 2 comma pi over 2. This time it's going to be row 5, group 4. That means you two. So Mr. Larson, tell me how to proceed. This one, 2 comma pi over 2. I'll start with the angle. Where's pi over 2? Okay. You put it at 2. Here's my first ring. That will be 1. Here's my second ring. That will be 2. There's the dot, that red dot right there. Okay, and let's move on. This will be row 6. 5, that's the back corner. Okay? Pi over 4, which is this line that runs right there. 1.8 or maybe 1.7, somewhere in that zone. I'm going to put it right about there. There. Now, wouldn't it be kind of nice to have something that's on that bottom line? Like to know where the point would be, like in here, or would it be like there or there? It'd be kind of handy to do that. So what angle is that? 0. So I could force it to work. I could go 1 plus sine of 0. What is sine of 0? Well, I'm going over to 0. Sine is the y of it. It's 0. Now make it 1. There we go. I forced myself to have a point right there. At least I know where the point is that's on that line. All right. And now, these can turn out to all different crazy kind of things. Maybe this thing is going to end up being a heart that kind of looks like this. Sometimes they're a half circle. Sometimes they're a circle. This could just be a circle that goes around like that. There's so many different options. If we graphed a million points, we would end up seeing all of it. We could figure out where it was. Okay? So, but I don't expect you to look at this and go, oh, I know what 1 plus sine of theta looks like. I don't. Yeah, I just know how to find a few points on it. And then if I find enough points, eventually I can see the pattern, and you won't need to know those patterns. Okay. Now, let's find the homework for today. I'm going to pause while I pull that up. Okay, so to keep it simple, your assignment is these two, all of these, and all of those. And that may seem like a lot, but it isn't. It's not that tough. We're stopping at 93. Okay, let's go back to the beginning. Remember about the intersection thing? How do you do the intersections? You could graph them and see where they cross, but a lot easier to set them equal. How? Substitute. So we're going to substitute r equals 2 sine theta. So I'm going to replace the r with 2 sine theta. Now, this is a tough equation. 2 sine theta equals 2 root 3 cosine theta. We did one similar earlier. Remember it? If I'm trying to get this thing solved, like I can't just stop there. The question isn't just translate polar into rectangular or something like that, where you just, once you get it changed, you're done. You have to solve this kind. I got to get theta alone. Divide both sides by what? 2 would help. That makes it cleaner. And cosine is correct. And that way, the cosine cancels the cosine. The 2 cancels the 2. And sine over cosine turns into tangent. And you can solve this then, because it's 2 tangent equals root 3. And from there, you ought to be able to get the 2 answers. And the answers are angles. Oh, that 2 canceled? Awesome. Then it's just tangent equals root 3. Sorry, you're right. Those 2's canceled. So then, that's TOA, right? Oh, students, take calc. Tangent's positive. Stay. Tangent's positive, so it has to be in these 2 quadrants. Don't make me talk about it further. All right, tangent is TOA, opposite, over adjacent. And that's a 2. There we go. Oh, I can tell which one that is. Pi over 3. And another one. All right, so there's help on getting the first one going. This one is similar. I want to warn you, in this problem, you will need common denominators.
Yes.
All you have to be able to do is find a common denominator when you're solving this puppy. That'll go in there. And when you're done, you get 2 angles. Because the answers are to find theta. The angles where they intersect. All right. Now, I know it says find intersection point. If you find the angle, how can you figure out what r that is? Let's say that the angle comes out to 30 degrees. If I figure out that that angle was 30, where they intersected, can you see that I can figure out what r is right there? So once you found the angle, You can go back and stick it into the equation and you can figure out r. All right, I'm going to give you a little bit more of a hint. I know we're almost done here, but we're not quite. What's x squared plus y squared? Hey, stay quiet and sit still. Okay, that's r squared. Then, this one, there are no x squareds and y squareds, so you can replace x with r cosine and y with r sine theta. Okay, good. And on this page, this is the one that's the trickiest. I'll just get you started. Would you agree that that's an angle? It's saying that angle and every radius. That angle goes here, and every radius means it would be like that. The question is, that red line has rectangular coordinates. It's a line that goes straight up and down. All right, we're stopping at 93. That's all I got for you for today.